Okay, so we're going to use the normal curves again today, but you need your graphing calculator because your graphing calculator actually has the ability to find the areas under the normal curve with anything. It doesn't have to be on those strict standard deviation lines. So that's what I need to teach you today. How do you find area? This is all area, by the way, proportions, percentages, or probabilities. When the area does not fall between exact standard deviations. That sounds really fancy. Okay, what I mean by that is what proportion of bottles are filled with amounts between 498 and 504? Scroll up on your paper. Okay, and do you guys see how 498 isn't exactly one of these lines? And 504 isn't exactly one of these lines. Okay, so that's what we need to figure out today. How do we do it when the values that we want aren't exactly on one of these lines? Okay, as I said, your calculator has the ability to do this in about 2 seconds, which is great. The first thing you need to know is some notation. So we need to find the calculator function, which would really help if I had my calculator. Look at my bag. I think it's in the big section. Yeah, that guy. Okay, thanks. This is my child, by the way, my teacher's assistant for the day. My child is visiting. He brought me Diet Coke. He's the best. Okay, anyway, if you ever wondered what a small, he's not a Talbot, he's an Ide, but anyway. Okay, so, okay, I need you guys to find this menu. It says Dister. Find the Dister menu. And remember, when you use your graphing calculator, anything in blue, you want to hit the blue button first. So hit second vars to get into the distribution menu. Dister is short for distribution. In this section, you're going to find a lot of the stuff that we're going to do for this whole year. But these top 3 are the ones we're working on right now. Normal PDF. We will never use that one. Okay, let me explain what it does, but we're never going to use it. Normal PDF is for normal probability density function. And it is going to be used to graph a normal curve on the graphing calculator. I am never ever going to ask you to graph a normal curve on a graphing calculator, because why would you do that when you can just draw a sketch of one and label the standard deviations like we did yesterday? It would be like a lot of work for nothing, because you'd have to copy it down on your paper anyway. Okay, what we want is the second guy called normal CDF. Normal CDF stands for normal cumulative density function, which means it's going to find the cumulative area for you between 2 values. So if you guys could go to normal CDF, please, and I want to show you what its requirements are. It needs 4 things. So scroll down, enter. Okay, and it's asking you for a lower bound. Don't get freaked out, calculus people. This is not limits. It's asking you for a lower bound, an upper bound, the mean, and the standard deviation. Okay, so we're going to label those things over here. What do we know about this problem? We want to go between 498 and 504. So our lower bound is going to be 498. Our upper bound is going to be 504. The mean, we're going to have to scroll up for that. Can you guys tell on your graph above what the mean was? 502, nice. And standard deviation was 1.8. If you're lost, these values were up here in this problem, the printed out Mr. Talbot version. Okay, now I want to make sure that you show your work properly to get enough credit for the AP exam. They are very specific about what kind of work they want you to show. You can either write this in the calculator command, but I'm too lazy. So I'm going to show you what I do. Okay. Now I want you guys to, you're taking my word for it, which is great right now. I want you to put in your lower bound, your upper bound, your mean, and your standard deviation. And then I want you to paste, and I want you to see that what it pastes is exactly what I wrote on my paper. You guys are going to get really in the habit of it. It's just your first time. It's okay. Okay. Now, College Board says if you want full credit, you can't just write this because not everyone in the world has a TI-84. They don't know what you're talking about. So you need to label. Okay, here are your options. You can write this and just the calculator statement, or you can write the calculator statement with the stuff labeled for full credit. Does that make sense? Okay, and then hit enter. And I round to the nearest 10,000, so 4 decimals. Okay, now for the next one, we're going to get our packet out and find one of those blank normal curves for me. What? Yeah. Yeah. Any blank normal, little normal curve in your packet, we're gonna go, we're gonna actually draw this one. Now, I didn't draw the first one because it was very obvious what the lower and upper were. But sometimes they write it in an inequality type thing, like less than or greater than, and it's much harder to tell what the lower and upper are. So I want to draw a picture for my visually, no, that's not visually strengthened people. I don't even know what I'm saying. Visual learners. Thank you for my visual learners. Okay, anyway, it must be Friday. Okay, so I'm just gonna draw a little bit of this. I don't need the whole curve. It said specifically what proportion of bottles are underfilled, and then I translated that for you to be less than 500. So I'm going to take my curve and I'm just going to estimate where 500 would be. And then I'm going to say, okay, less than is going to be all of this part. So that's the less than section. Do you guys understand that that's less than? Because this is 502 and that's 500.2, and then this would be everything less than 500. Okay, now this curve, you need to know that it goes on forever. And so what we're looking for is our low bound to be forever this way. What do we call forever in this direction? Negative infinity. Okay, so negative infinity to 500 is what I'm looking at here. So my low is negative infinity and my high is 500. The visual is really, really going to help you guys. Okay, now go back to your notebook paper when you're ready. Okay, and remember it goes low, high, mean, standard deviation. So my low is negative infinity. And unless you're using a TI Inspire calculator, your calculator doesn't do negative infinity. So in stats, what we do is negative 10 to the 99th power. So we're going to call that, that's what we're going to say all year for negative infinity. That's about as much as your calculator can handle. So that will be your low. 500 will be your high. Your mean is still 502 and your standard deviation is still 1.8. Do you guys like labeling on the thing or do you like listing? Either way is fine with me. No, you can do one or the other. So your choices are this or this. But that's full credit for College Board. I just want to make sure you guys are set. Okay, so going back to your second vars will get you back in your distribution menu. Second vars. And then one of the really good things about these calculators is they'll save your previous stuff. So it still has my same mean and standard deviation in there. I just need to make this negative 10 to the 99 and 500. Okay, pause right there. Any questions about anything so far? Are you sure? Are you positive? Table 9. Do you have any questions? Are you sure? I'm right here. Available for questions. Do you want me to show you the calculator again? Okay. So I don't know. I feel like there's confusion, but maybe there's not. Okay. My child here is not taking stats, so he is. The whole curve, if you did negative infinity to positive infinity, it would be 100%. These two should not add up to 100%. No, because this, okay, let's look visually. This one is between 498, 504, which is like here to here. Yeah, and the other one is less than 500, which kind of like overlaps it. Okay. Give you a minute to set this up. We need to do more than.
When Miss Talbot,
Mhm.
can we sing happy birthday for Justin?
Can we do it at the end, please? He sounds stoked. The world is our oyster. If you want to. We could go for a walk downtown. Go back to Napa, hang out, go see. I think that one, like maybe because she went to summer school, but she got a D in summer school, so. Oh yeah, that's perfect. Okay. All right. Are you guys done with the first two writing them?
Yes.
Okay. So next one is a more than, and you guys can probably figure out the pattern. So 502. That's wrong. It's because I have adult ADHD and people keep talking and I can't focus.
That's funny.
No, sorry, I got an ADHD lesson from my son here. Okay, anyway. So, all right. Does my picture make sense? Okay, when you read what percent of bottles contain more than, you make a boundary at that spot and then shade up being more than. Are we good with that? Okay, so this is the moment of truth right here. This now becomes the low. This goes on forever. And my high is positive infinity. Okay, so low now becomes 503.5. High is positive infinity. You see how they like flip spots? Yeah, exactly. And that's what I'm going to write in my paper here. So I'm going to write normal CDF. Low is now 503.5. And I'm going, I don't want to write infinity. I want to write positive 10 to the 99. Five oh two 1.8 low, high, mean, standard deviation, and then I actually need to do the problem. second VARS, normal CDF, 503.5, positive 10 to the 99, 0.02023. Okay, I'm going to not write the sentence here, but when it asks you to, write your answers in a sentence, it's just like the third grade conclusion sentence, like you're just answering the question, not anything fancy. Okay. The next one, though, I am hoping that someone can recognize my vocab use. I used vocab on purpose here. Percentile is very important. Percentile is very specific. Does anybody know what the definition of percentile is? And I don't really even need the percentile. I mean, the definition. What I need is what is the inequality symbol that goes with percentile? Yes, less than or equal to. Beautiful. If you guys could memorize that, that would be awesome. Okay, now less than or equal to. So this means that we're going to do one like this guy. This is a less than or equal to situation. So does that make sense? Because it's shaded less than. Okay. So okay, so I'm going to look at my picture. My upper is 499. So my low is going to be negative infinity. And my upper is going to be 499 this time, not 500. Or how are we getting the hang of it? Is it? I just suggest that you guys picture that normal curve in your mind, or if you need to, just go to that page with all the extra ones and shade one in. Now this is the laziest I can get. I'm gonna scroll up to this less than one I did up here and hit enter and then change this to 499 because that's got my lazy 0.0478. Okay, we have done all of the going forwards. Now we need to go backwards. You know that ride at Santa Cruz is like you get in a little car thing and you go like around in a circle and then it stops you like halfway through and then it sends you backwards doing the same thing. That's what we're doing today. So now we just finished the forwards portion. Now we're going to do the backwards portion. And I'm looking at your calculators. I don't know if you guys are older. No, not that. I didn't mean it like that. I actually don't know what his calculator is going to do. This one, you're probably going to use online for. They have updated the software to make it a lot easier on the newer calculator. But if you guys have an older calculator, that one might need an extra tutorial session on your calculator. You can always grab one of mine for inverse norm. So calculators are like phones, they have operating systems, and they update them. And they have updated this section to be much easier on the newer calculators. Just to let you know, yes,
If you had a TI 89, would you be able to use your calculator to?
yeah. They're just gonna be impressed that, you know, one still exists out there. It's actually a dig on myself because I still have mine from college, so that was a joke on me. I really do still have mine from college. It looks exactly like that. Okay, anyway. Okay, now we're gonna go backwards. How do we find locations within the normal distribution given the area under the curve? So this time we have this, and we want to go back to the 499. Or we have this, and we want to go back to the 503.5. Okay. The lowest quartile of amounts of cola filled into the bottles is at how many milliliters? Mrs. Talbot, did you have to make the first one just so wordy? Okay, so lowest quartile is quartile 1. Quartile 1 is 25%. Okay, so this is saying the bottom 1/4 of the bottles have how many milliliters? Is what it's asking. Okay, I want you guys to take your normal curve, and then actually, I want you to look at your other normal curve, the big one. And I want to estimate where the bottom 25% would be, like, I don't know, here-ish. You thinking? Okay, we're just gonna use this to kind of help us draw that line. So we're gonna go here. We're gonna say, all right, bottom 25%-ish. It doesn't have to be perfect. And this is what this question is asking. What measure of location is the upper boundary of the bottom 25%? So going backwards, you have the area now, you're going backwards to the location. Okay, so now let's look at the calculator again so you can see what it requires and go back to that same menu. And because we're going backwards or undoing, we want inverse norm. Inverse norm is backwards. So normal CDF is forwards, inverse norm is backwards. Okay, now that you have, if you have an older calculator, you'll see why mine is better. Okay. So on the newer calculators, they let you specify left, center, and right. On the older calculators, they make you go with left every time. And so then you have to figure out what it would be for the center and the right using like common sense of the fact that it adds to 100%. Probably won't be an issue most of the time. But if you have an older calculator, and I pointed them out, and you don't have the left, center, right, you need to know that your calculator is working in left all the time. Always left. Okay. All right. So you write inverse norm. Okay. Now notice the first thing it wants is the area. Area needs to be a decimal. If you put 25 in there, you're going to feel really silly when it gives you an error. Yes, honey. Were you in normal CDF and then went to inverse norm? You have to get out all the way and then do it. So go second quit. Okay, anyway, while we're fixing that, make sure that your area is a decimal. Remember what I said about density curves, the area adds up to 1. So yeah, decimals, it's okay, because you're going to try to put 25 in there and then you're going to be like, there's an error, and then you'll be like, oh, right. So it'll catch you. Okay, mean is still 502. Standard deviation is still 1.8. And we're working with left in this case because it says lowest quartile. And I shaded the lowest quartile. So my tails, my areas to the left here. Okay, if you're doing this on an older calculator, it's just going to end the parenthesis right there. But we should get the same answer. Yes, Annie.
It's only left if it's, like, there's a percentile.
Okay, yes, it's left if it's percentile. If it says less than or lowest or something like that would occur to you to go to the left. So anytime you see like percentile, lowest, less than, low, like going down numbers. Okay. Less than or equal to for percentile. Okay. Oh, wait, really good question that just came up. Why did I not change what I said when we're talking about less than? I wrote less than. What about less than or equal to? Remember what I said, segments don't have area. It doesn't matter. Less than and less than or equal to are the same in area problems. Okay. How many, oh, do you guys have this one written down yet? Okay, how many milliliters is in a bottle at the 95th percentile? Okay, we're ready. Inverse norm. Percentiles less than or equal to. So my area is 0.95. If you want to, you can write 95th percentile 0.95 over here. 502, 1.8. It's left because it's got the word percentile, which means less than or equal to. Are you guys good? Are you getting it? You're okay? And then I'm gonna be really lazy to scroll up and hit enter and change that 2 to a 9. I did it wrong. I changed. $5.05. I know, I could have just typed it from scratch faster than that. $5.05. Because the word percentile means less than or equal to. Left is shaded to the left, so less than or equal to is always left. You can also just look at the direction the arrow is pointing. Okay, this is the end. Three more questions and we're done. We have to do more and we have to do center. Like more than, greater than, bigger than. So on this next one, the top 10%, I'm going to teach a new calculator way and I'm going to teach an old calculator way. And so I have cola. I didn't even realize this was going to happen today. I have illegal diet soda. Hmm? Extremely low, actually. Coffee is much higher probability. Tea, also a higher probability. How about we just do these three and be done? Because I think your question would actually be a lot harder to do. Okay, so can you guys get out your sheet for one last curve, one last small curve? Look at this, I even smudged my paper with my cola. There's actually a higher probability of that because I'm a clumsy human being. All right, so the top 10% of cola bottles starts at how many milliliters? Yay, more cola. So we are going to mark the top 10%. We're just gonna eyeball it. What do we think looks like about 10%-ish? So that's what this question is asking. And when you look at this, can you tell that it's going to be to the right? Okay, so if you have the newer calculator, I want you to see that this drawing implicates the fact that you're going to choose the right instead of the left in your inverse norm. Okay, so we're going to do inverse norm. Zero 0.10, 502, 1.8, right. And I have gotten lazy and didn't label up here. You guys should fix this if you didn't do it. Okay, if you have an older calculator, your calculator works in left. So what you're going to do is you're going to say, okay, the top 10% is the same thing as the bottom 90%, and you're just going to put 0.90 in here. 0.10 to the right is the same answer as 0.90 to the left. Okay, but anyway, so inverse norm, 0.10. Now to the right. Paste 504.3. Okay, now we need to do the middle percent. If you have a new calculator, you could do this with the center inverse norm. If you have an older calculator, you're going to have to do two different keystrokes. So hold on to that thought. All right, so give it a go. And you might be surprised to find, okay, be surprised on your own time. So I'm just being funny. So, okay, so there's two answers. The first one is 499 and 505. Okay, but why does this make sense? Okay, so middle, let me draw you a picture. Middle 90%. I'll draw you a picture on here. Okay, normal curve, it's going to be bad. Just prepare yourself. Okay, so 100% minus 90% divided by 2 is 5% here, 5% here, but aren't there two answers because it's asking you what two values form the middle 90%? What's the low and what's the high that give you the middle 90%? Yeah. Well, kinda, yeah. But this is 90% in here, and it's giving you the low one and the high one that gives you the middle 90. So whenever it asks you for the middle ones, you're gonna have to find two because there's a low boundary and a high boundary for that. Okay, now, if you do not have a newer calculator that can do that, what you're gonna do is exactly what I just did a minute ago. You're gonna say, okay, my calculator works in left, so I'm gonna do an inverse norm for 5%. And I'm gonna do another inverse norm for 95%. Then 5% will give you this spot, and the 95% will give you that spot. How did I get those? I went 100% minus 90% divided by 2. That gave me the 5%, and then I added the 90 onto there to get the other one. Or on test day, you could just grab one of my calculators and do that. That's fine too. But this is how you do it. Okay, last one. What is the z-score at the 70th percentile of filled bottles? Last problem of the day. Okay, let's pick this apart step by step. What does percentile mean? Perfect. Less than or equal to. Great. Okay, so we know that that means we're going to do left, which is just a great relief for those of you that have an older calculator. Okay, 70th percentile. What is the decimal for 70th percentile? 0.70. Beautiful. Okay. I know I'm doing inverse norm because they gave me a percent, which is an area. But it's asking me something very specific, and I'm kind of baby stepping into what we're doing in the future. But let me remind you of this. These are z-scores, correct? What is the mean of this distribution? 0. What's the standard deviation of this distribution? 1. So if you're looking for z-scores, you need to use the standard normal curve where the mean is 0 and the standard deviation is 1. So you're going to say, oh, z-score. Mrs. Talbot told me that was a standardized score, so I need to use the standard normal. So mean equals 0, standard deviation equals 1 when you see that. Inverse norm, 0.70, 0, 1. Do you guys notice that your calculators default to that? The standard normal? It also puts that scientific notation 1 times 10 to the 99 in there a lot of times. 0.5244. Okay, now you're like, pause real quick. I know you want to be done. This feels like an area though. It's not an area. Okay, it's a z-score. I want you guys to look at what kind of numbers are here. So 0.5044 would be like the location right there. And wouldn't it make sense that everything below that is about 70%? So look here, there's 50, there's 84. So it makes sense that it's a decimal. Whatever you say, Mrs. Talbot. All right.